Let's practice more with linear applications. For a warm-up, the North Georgia Fair costs $6 for admission plus $1.50 per ticket. Part A, we're going to write our function g of t that represents the cost of admission per ticket. So in order to get into the fair, you have to pay $6 no matter what. So that is, if you buy 0 tickets, you're paying $6. So that is our y-intercept, or our initial value. And the $1.50 per ticket is what you're going to pay for each ticket that you buy. So that is your common difference, or your slope. So if we're writing this in slope-intercept form, that would be g of t equals 150t, that stands for $1.50 per ticket, plus $6, which is our admission. To find the cost of 10 tickets, the easiest thing to do is to substitute 10 in for t. So you're going to do $1.50 times 10. That means you're going to pay $15 for tickets, and then you're going to add $6. So that's going to be a total of $21 for 10 tickets. The cost to attend prom at Milton is $26 more than 3 times the cost of a ticket to homecoming. Write the function P of H to represent the cost to attend prom. Okay, so we know it's going to be P of H equals. So 26 more. When you're saying that it's 26 more, that means you're going to be adding 26. But what are we adding 26 to? We're adding 26 to 3 times the cost of a ticket to homecoming. So 3 times that homecoming ticket price. So 3 times H, or just 3H. So prom will cost 3H plus 26. So what is the cost for a prom ticket if the homecoming ticket is 24? All right, well, let's put 24 in for H, because H represents the cost of that homecoming ticket. So we're going to do 3 times 24, and then we are going to add 26. Again, you can do the mental math, you can use a calculator. If you're going to use a calculator, please make sure you are practicing using that Desmos calculator, either the app or on your online. Just go to desmos.com. There's the scientific and there's the graphing. The scientific is good for this because we're not really trying to graph, but it would work just the same. That would be $98 for the prom ticket. Example 2, the number of kids at Wills Park swimming pool each day is the sum of 13 and 3 times the number of adults. We're going to write our function. We're going to call this WA. Okay, and A is going to represent our number of adults, and W of A is going to be our total number of kids. So the sum of 13, sum means we're going to add 13, 3 times the number of adults, so 3 times A, or 3A. For part B, if there are 18 adults in the pool, how many kids are there? So let's plug in 18 for adults. So we're going to do 3 times 18, and then we're going to add 13 to that. Again, either do the mental math or use a calculator, whatever you prefer, but that is going to be 67 kids. For number 3, the length of a rectangle is 3 more than twice the width. For A, we're going to write a function P of W to represent the perimeter of the rectangle. So I find that a picture is very helpful for this. Hopefully we all know what a rectangle has. Typically, a rectangle has a length and a width. You can also call that a base and a height. So let's just call these ones length and these width. But we know something about the length. We know that the length is 3 more means you're adding 3, twice the width. So what we can do is we can, instead of writing L, we can take those L's out and we can replace them with 2W plus 3. So to find our perimeter P of W, if you remember, to find perimeter, you add all of the sides. So I'm going to add all of the like terms. So we've got 2W, 2W, W, and W. So 2W, 2W is 4W, 5W, 6W. So we got 6 total W's. And then we're going to add the constants. The constants, we've got a 3 and a 3, and 3 plus 3 is 6. So our perimeter is going to be P of W equals 6W plus 6. And then for B, it wants to know the perimeter if the width is 9 centimeters. So that means W equals 9. So we're just going to substitute 9 in. So P of 9 equals 6 times 9 plus 6. So 6 times 9 is 54. And 54 plus 6 is going to be 60. So our perimeter is going to be 60 centimeters. So our last question is similar to number 3. This time we have the width of a rectangle is 15 less than 4 times the length. So I'm going to start by drawing that rectangle. And again, we normally have lengths and widths. But this time we know the width is 15 less than 4 times the length. So 15, width is 15 less means you're subtracting 15. So make sure you don't do 15 minus, make sure you do minus 15. And then 4 times the length means 4 times L. So in my picture, I'm going to take those widths out this time, not the length. And I'm going to change those widths into 4L minus 15. So this time our model is going to be P of L because it's the length that this is written in terms of. So when we find the perimeter, we're going to add all of the like terms. So I'll start with all the L's. So we have 4L and 4L, which is 8L. Plus another L, which is 9L, plus another L, which is 10L. So 10 total L's. And then we're going to look at all of our constants, and we have a negative 15 and a negative 15. And negative 15 and negative 15 make negative 30. So our perimeter can be represented by 10L minus 30. So now we're looking for the perimeter when the length is 10. So we are going to substitute 10 in for length. So P of 10. We do 10 times 10, which is 100. And then we're going to subtract 30, which is 70. So our perimeter will be 70 feet.